Welcome to lesson number 6. We're going to be looking at solving quadratic equations using factoring today. So this is the first lesson where you kind of get to think about why we factor. So if I have something that's set up as an equation, so for example, if I have this statement, x minus 3 is equal to 0, so this is only true if x is equal to positive 3, because 3 minus 3 would equal 0. In this statement, x plus 1 is equal to 0. This is only true if x is equal to negative 1. So negative 1 plus 1 would equal 0 as well. In this statement, and this is where we get the zero product law from, x minus 3, x plus 1 is equal to 0. This is only true if x is equal to 3 or if x is equal to negative 1, because we would be multiplying either one of these binomials by 0. So the statement x times x plus 1 is equal to 0. If this value of x were equal to 0, the whole thing would equal 0. So we would say if x is equal to 0 or if x is equal to negative 1. Now, what this is called is the zero product law, where one of the factors must be equal to 0. Now let's take a look at what's going on in this investigation. So if a times b is equal to 0, then a must equal 0 or b must equal 0. And then we'll complete the following by solving for x in each equation. So in order for this statement to be 0, we would have to have a product of 0 here. So x would equal 0. In this example, x has to equal negative 2. So one way we can think about this is x plus 2 needs to equal 0, or x minus 7 needs to equal 0 in order to make this equal to 0. If I solve for x, x would equal negative 2, and x would equal positive 7. All I'm doing is I'm just balancing out my equation in order to make one side equal 0 and to find my solution for x. So if we have something like example A and B, why is it acceptable to divide by 8 first in A or B? So one way we could solve for x is if I were to divide 8 out of my equation. So divide 8 out of my equation. So if I divide both sides by 8, I'm going to end up with the same constant value, and that means I'll end up with the same solution. So if I were to go 0 divided by 8, that's just going to say x is equal to 0. Why is it not acceptable to divide by x first in question C? So when we have question C here, if I divide by x, we're not going to yield the same. We're not going to yield the same result, because if I divide both sides of an equation by a variable, it's not going to be valid until we know that that variable itself can't equal 0. And so this variable here can equal 0, so we won't be able to divide it by x. Now let's take a look at a few different examples. First of all, we're going to look at class example number 1, where we're going to solve a quadratic equation. So we want to consider the equation x squared minus 2x minus 3. This is something you can probably easily factor, and if you do, you're going to get x minus 3 and x plus 1. And in this equation, however, it equals 0. So this is true if x is equal to 3 or if x is equal to negative 1. So if x has either one of these values, it will then equal 0. So if I have this equation, and if it satisfies both x equals 3 and x equals negative 1, then we would say that the solutions are going to be 3 and negative 1. Sometimes it's written like this, where x is equal to negative 1. In this case, we would put the lower valued number first, so negative 1, and then positive 3. So complete this solution to the equation, x squared minus 9x plus 20 equals 0. Now, if I have x squared minus 9x plus 20, the first thing we got to do, as it's kind of indicated here, is we need to factor this. And so what multiplies to give me positive 20, then adds to give me negative 9. Well, we would have negative 4 and negative 5. And so if I think about these individually, x minus 4 needs to equal 0, and x minus 5 also needs to equal 0. So what we would say, if I were to solve for x, I'd have to add 4 to both sides, which would result in x equals 4. I could also add 5 to both sides, in which case x would equal positive 5. Now the solutions are going to be x is equal to positive 4 and positive 5, or we could say x is equal to 4 and 5. Now we want to solve these using the zero product law, exact same thing that we just did. Notice how you're going to run into the same type of factoring that we've been practicing. And this is the reason why we've been factoring in the first place, is so we could get to this point. Now, x squared minus 81, this is a difference of squares that I have here. So I know that this is going to be x minus 9, x plus 9 is equal to 0. And if I take both of these, set them equal to 0, x minus 9 equals 0, or x plus 9 equals 0, I'm going to get a value of x is equal to 9, or x equals negative 9. And if we were listing both of these, we'd say x equal to negative 9 and 9. That would be our final answer. Now, with this example, so I'm going to skip a few. So we have another difference of squares here. This one, 10x squared minus 90x. What I can remove from this is 10x, leaving me with x squared minus 9. And so I have 10x times x minus 3 times x plus 3. And if I take this one, I'll set this equal to 0, 10x equals 0. And I have x minus 3 equals 0. And I have x plus 3 equals 0. This is going to be a value of x equals 0, x equals negative 3, and x equals positive 3. And we will look at a couple more examples in class.